Palo Alto College is planning to construct a rectangular parking lot on land bordered on one side by a highway. The plan is to use 640 feet of fencing to fence off the other three sides. What should the dimensions of the lot be if the enclosed area is to be a maximum? Now, pictorially, we want to construct this parking lot along a highway. It's rectangular in nature. If we let X represent the width of that parking lot, this is a rectangle, so our bottom dimension is also X. We're given that the plan is to use 640 feet of fencing to fence off these three sides. So the sum of these three sides is 640. That leaves our other dimension, the length, as 640 minus what we used for those two sides, or 640 minus 2x. Let's see if we can write an equation. Here's our picture. X is the width. 640 minus 2x is the length. And we want to maximize that area. Well, the area of a rectangle is length times width. Here we have a length of 640 minus 2x. We've defined our width as x. We can write this then as an area function in terms of x. Let's clean this up a little bit by multiplying through. That's a 640x minus 2x squared. And I'm going to switch terms and write that as a negative 2x squared plus 640x. Now let's pause for a minute and realize that we are dealing with a parabola here, a quadratic type of function, a parabola. This leading coefficient is negative 2. And a being negative 2, that's a number less than 0, indicating that that's a downward opening parabola. So our area function is a downward opening parabola. We want to maximize it. Therefore, we're looking for that vertex. So let's go about finding the vertex for this parabola. I'm going to use the formula x is equal to negative b over 2a for finding that x value of the vertex. In our function, b is 640, so that's a negative 640 divided by 2 times a, which is negative 2. We'll be dividing negatives, resulting in a positive value, and 640 divided by 4 is equal to 160. So as we think about that vertex, it has an x value of 160. But we're actually asked to find, okay, now what's the area value when x is 160? So now we want to find the actual minimum area. We'll find that by plugging or substituting 160 in for x in our area function. In other words, we want to find the area evaluated at x equal 160. Substituting 160 in for x, this is a negative 2 times 160 squared plus a 640 times 160. And at this point, I would probably use a calculator to help me do that quickly. That is equal to a 51,200. We had dimensions in terms of feet, so this also is in terms of feet, but feet squared. So let's make sure we've answered the question. The question was, what is the maximum area for this parking lot? Well, our maximum area is 51,200 square feet. That occurs when we've got dimensions in here of x equal 160, and that other dimension then is a 640 minus 2 times 160. That's a 640 minus 320, or 320. So 160 feet by 320 feet gives us a max area of 51,200 square feet.